Well, and let's begin. Our first Martian today is Roksolana Diachuk. Roksolana works as a big data engineer at Captify. She's passionate about big data, Scala, and Kubernetes, and she always loves to learn something new. She is a woman who code Kyiv, one of the leads, and enjoys organizing events just like us, as well as speaking at them. So it's very great to have you here. And let's hear Roksolana Scala meets Kubernetes. And of course, if you have any questions, don't forget, you can type those in on Pine, and I will pass them on at the end of the speech. Welcome.
Thank you. Morning, everyone. I'm happy to see everyone who came to this talk. And basically, as the name says, we will learn how to use Kubernetes from Scala. But actually, why Scala? My primary programming language is Scala, therefore all of the examples will be in this language. But I think it would be useful for anyone who doesn't even know what Scala is, because it's JVM-based language. So if you ever use Java or Kotlin, I think something will be familiar for you, and just in general, it would be useful to see what kind of libraries you can use for other JVM languages. So I'm Roksolana. I work as big data developer, and Captify is the largest independent holder of user search data outside of Google. It's a British tech company with a tech product, and the engineering team is between Kyiv and London, and I'm based in Kyiv. Also, I'm diversity inclusion ambassador there, and Women Who Code lead, and I often speak at conferences and multiple meetups. So for the agenda, first of all, we are going to explore a little bit what is Kubernetes, what kind of objects exist there, how it works a little bit behind the scenes. Then we will get more to the link between Scala and Kubernetes. And then we will explore a little bit more of theory for specific practical examples, because there will be some specific objects we are going to create. And then I'll dive into some practical examples. Okay, first of all, what is Kubernetes? Actually, I can't say that Kubernetes is a framework, because it kind of encompasses so much things. I would say that it's more like a system or infrastructure, which basically allows us to deploy our applications in a more automated fashion, to build our own infrastructure. And it has so many objects that you can choose from, so I think it kind of has a high learning curve in a way, and that's why a lot of people are a little bit scared of it, although it's quite hype word in the recent years. So talking about Kubernetes objects, these are just a few of the many that exist in Kubernetes, but just to explore these, like the most basic ones which we would usually use to deploy the application. First of all, there is a pod. Probably many people heard about it. It's just a single unit of work, like the most simple small entity, and it usually contains one or multiple containers, so you can deploy an application using just this simple pod. But it doesn't have like much functionalities aside from that. There is a more complex entity like replica set, and it doesn't have also kind of extensive functionality. It's more just adding up the copies of the pods. That's why it's called replica set, the replicas. So we are able to run multiple pods within the replica set. And even if we will go like upper by this hierarchy, we will get to the deployment. So deployment is like more complex than both pod and replica set. So we have multiple pods in each deployment, and we have some additional functionalities. For example, we can perform some rolling upgrades, because we can have like this setup for each of the pods. We can label the pods. We can set up some additional volumes for the data storage for this deployment. So we have like this additional functionality for the deployment, and most of the cases I would say that this is the object we go for if we want to deploy something. Not the pod, not the replica set. Just because deployment is kind of easier to use, it's more extended already, and why we would use like specifically the pod if we can use something more complex. Also, there are two kind of similar objects, but they work for very specific use cases, like stateful set and daemon set. So stateful set works just judging by the name, for deploying applications with a state. So if you want, for example, to set up a database, stateful set is a good choice. And it allows to set up some kind of volume for storing the state. Also, stateful set have these very interesting features that they allow to set the ordering of the parts of the stateful set. So if in deployment we have some usually randomly generated names for each of the pods, in stateful set we have ordered names like pod 0, pod 1, pod 2. And why it's good? Because actually sometimes we need to perform some, for example, upgrades of software in specific order, or we want to reach out to specific pod in specific location, and therefore it's good to have this ordering. Daemon set is, I would say that it's not very widely used, but it's more like on the background, because daemon set allows us to run each copy or pod on the node of the cluster and gather some logs, gather some metrics for monitoring. So it's more like this service utility. And there are two more, service and volume. They are kind of an abstraction because there are so many kinds of services and volumes. For example, talking about the volume, it's just for storing the data, kind of like a directory, if you would imagine that. And the volume can be depending on the cloud provider, so there can be like Google Cloud volume, Azure, or persistent volume. In services, same way. We can have different services like load balancing, usual services which we use for some port forwarding. So again, multiple types depending on the needs. So now we are going to explore a little bit what happens behind the scenes, aside from just having these objects. We have a kubectl, which is a command line. And the command line basically allows us to write some commands, and these commands are translated into the requests, which are sent to the API server. API server is this entity which contains the information about the Kubernetes API objects, and it helps to kind of authorize our request. So we want to create something, API server authorizes that, yes, it's the proper name of the object, we can create it. Also, there is etcd, which is a key value store, persistent key value store. Persistent means that it's not tied up to the life cycle of the object it connects to. So if this object somehow gets deleted or disappears, we still have the data. So etcd stores everything about the cluster, all of the objects that we created, and usually when we send requests to the API server, it goes to the etcd to check if it's the right one. So, for example, again, creating the deployment, so we need to check that it's the proper name, that we have such objects. Because if you would write some kind of typo, like, I don't know, deployment something, we would get like unauthorized requests because there are no such objects in Kubernetes. The next one would be controller manager, and the main purpose of controller manager is checking the desired nature and the actual one in our system. So it's kind of helps to provide this declarative nature of Kubernetes. Desired nature is something that we define in YAML files or in our commands. For example, the amount of pods, the objects that we want to have on our system, and the actual one is basically what it is in a specific moment. For example, we want to create something and we don't have any pods at all. So our actual state is that we don't have pods. The desired one would be to create, for example, 2 pods. And in such a way, controller manager figures out that we actually need to create something because our desired state doesn't coincide with the real one. And then it can connect to the scheduler. Scheduler basically checks all the time if there is something that should be created and scheduled or rescheduled in case of the failure. And therefore, the scheduler can schedule new objects. So how it looks like for the pod, just all of the same parts of the Kubernetes or components that we discovered in the previous slide. We send the request, kubectl create pod. This request is translated to the request to the API. Then API server checks in etcd that actually we have pods, we can create them, and we have an authorized request, that we have enough writes in a specific cluster to do that. Then API server connects to the controller manager. Controller manager sees that we have 0 pods, but we asked for 2. And therefore, it can connect to the scheduler, and scheduler in its turn schedules pods. What happens on the right side? We have 2 new entities, kubelet and kubeproxy. Both of those run in specific node of the cluster. So if you want to schedule a pod, the kubelet usually monitors the state of this node and helps to connect the node of the cluster to the API server. So the kubelet gets this request, helps to schedule the pod, and later just monitors the health of this pod. So if anything happens, like any kind of failure, it will report back to the controller manager and scheduler, and they will kind of handle it from their side. And there is a kubeproxy. It's just a proxy, a networking entity, which helps to connect the pod to the outside of the cluster or to other objects within the cluster. So just like that, when we just run one command, that's what happens behind the scenes. Also, you can notice that each pod can have one or multiple containers. The usual case is to set up one container for each pod because it's kind of like single entity, easier to manage, easier to build connections between other pods or other entities. While in other cases, we can have multiple containers in one pod, and it would be like very specific case when you have very connected containers. For example, they use the same storage, the same data. But usually, just stick to the rule of having one pod and one container. So now get into the question of Scala and Kubernetes. We can obviously use Kubernetes from any kind of programming language using different libraries that act as clients to the API. Basically, they just send the requests to the API, and then we can create objects or modify them in any way. So the same thing exists for Scala, and there are multiple libraries to do that. So we're going to explore in general multiple ways you can do that. So there is Java Kubernetes client. And this Scala is a JVM language. You can use Java Kubernetes client as well. It's an official client for both Java and Scala, but it doesn't really have like extended functionalities. It has very basic functions, so if you just need to create objects or modify them, it will be enough for you. But if you want to create something more complex, like the pipeline, some monitoring, it would be not possible basically with this library. So it has just limited functionality, but it might be enough to just practice. Another 2 libraries is Fabricate.io and scuber. Fabricate.io is Red Hat community library, which is also written in Java. So it works for multiple JVM languages. It has much more functionalities than the Kubernetes client that I previously showed. And it allows to build more complex pipelines. But I would say the drawback for Scala developers or other JVM languages developers, not Java, is that all of the examples would be in Java. So you kind of need to mentally translate it all, and the source code is in Java. But for most Scala developers, it's kind of okay to go through the Java source code. And scuber, it's a very small library. It's not set up in documentation as an official client. But it's heavily used by Scala developers because it's written in Scala. And all of the examples, everything in Scala, and it relies on Scala libraries. So we are going to explore both of these libraries in this session. Talking about choosing the specific library and the drawbacks and advantages. So Java Kubernetes client, as I mentioned, is written in Java. All of the examples, the source code, actually the code is generated by the Swagger, so it's kind of hardly readable, and it's hard to fix some issues because I would say that kind of long time to get replies for some GitHub issues, so it might be not so fun to use. And just as I mentioned that the functionality is not really extensive. You can create something, update, but not more than that. Then Fabricate.io is that you can use this library for more things to do. For example, monitoring, getting the logs from the pod, setting up the pipeline in such a way that you wait for something and then hook something else. So it's more fun to use. And it's written in Java, and it's also an official client. And scuber is a library that I mentioned, which is quite small. So I would say that it might not be very good in terms of support because only like a fraction of people uses it aside of other official clients, which have much more support and you can write about some issues. But this library is better for Scala developers because it's written in Scala and it relies on Akka library. Okay, so getting to the practical examples, I'm just going to tell about the concept a little bit of the examples. So I thought of the issue when, for example, we already have a Kubernetes cluster set up for us, or we set it up, and we have some applications running in this cluster. So later we need to set up something close to the infrastructures that we have in production for testing, for example. And we want to do that in either unit tests or integration tests. So in order to do that, we need to set up this infrastructure from scratch, then explore everything, set up all the objects, modify them in the necessary way. As soon as we do that, we can get to the running the tests, and after that we need to purge this infrastructure. So it's quite simple, and we are going to explore it for both of the libraries and see how we can just set up the infrastructure from scratch with different objects, and how we can just remove it all and see how it's different for both of the libraries. So I'm going to show the code. I hope it's not going to be loading for too long. For some reason, my project ran out. Okay, I'm just going to show you in IDE, but it might not work with the compiler. Can you see the code I'm opening up? Is it too small or is it fine? Okay, so we have the first is a pod test, I called it. So we are going to create simple pod. Just going to put it full screen. Yeah. So we have this pod. So we set up the Kubernetes client, the namespace, let it be test, doesn't really matter. And we set up some name of the pod. So that's how the description looks like. I don't know if you've seen the YAML files to know how it looks like in comparison, but it's very similar in terms of structure. So we call the pod builder, we set up the metadata part. Metadata contains something like name, labels if it's needed, so you can see with the name that we set up, adding labels, we set up any label that we want. In this case, it's going to be some simple nginx. And that's when metadata part is finished. The next one is spec or specification part, and it contains more detailed information about the entity. Like in this case, it's a pod, so we need to set up the container with the name nginx. The image is nginx and version of this image, and we set up the parts because nginx needs to have ports. So we have add new port, container port, we need to expose it from the container, and this part is finished, and here's like the end of the container specification. And after that we can end the specification part and run build. So this part here is actually just a blueprint. When you are going to type it, nothing happens. So before, it's kind of like just what we want to have. It's just like writing down the YAML file. But before you even run something like kubectl create or provide this YAML file, nothing happens. You have just at least design of what you want to have. We can call it a desired state, as we mentioned before. So then we can actually create it by running pods method on client, then checking that it's in specific namespace that we mentioned, and calling create with a pod. After that, we can do this. We can just run pods in namespace and list them. So we are going to kind of like check that our pods got created. So we have pods in specific namespace, list the number, and we get the size, just like getting the list and checking that we have like 2 or 3 pods that we created. And here I didn't like write the specific task because it would definitely depend on the applications that you're creating, but it can be anything like checking up how the application is running, the results, and it's all based on some specific pod that you created. For example, interacting with Nginx. And in the end, we can call client pods in namespace. Some namespace with a name and call delete. And here I'm just put some waiting times for like thread sleep because actually the pod is not created or deleted instantly. We obviously need to wait for some time, although it's quite short. But anyway, we sometimes need to put this kind of waiting time to just get everything properly deleted and created. And in the end is a similar thing just to check that we've got the proper pods deleted. So you can see here already kind of a drawback is that we are checking the pods in the namespace, which wouldn't work in the cluster environment because you can have, I don't know, thousands of pods or hundreds, so checking everything in the namespace wouldn't really be like a good approach. So I can show you a little bit later in other examples how we can check by the labeling that we can set up and see that we are running only for specific pods. The next example is about a more complex entity replica set. You can see that the setup is just the same. We have the client, the name of the namespace, the name of the replica set that we set up, and those are like supplied in the beginning. And here again we have before all method, and replica set here is created by replica set builder. In that case, if you remember, was a pod builder. So this API kind of allows to specify what you're going to create. And here, the description itself, the blueprint is much, much bigger. So I would say in a way, it looks like creating a YAML file is kind of similar because it's also going to take some space. It also has some predefined default parameters like options, metadata, specification. So it's a bit tedious to set it up like yourself, and I would say that it's hard to memorize, and it's more, in a way, graphical when you set up. It's in YAML file because you have a format. So you specify this metadata, the name, and the labels in this case. So it's kind of more complex already. And the specifics of replica set here is setting up the number of pods or replicas, which could be 2 in this case or more. And then there is an important part which is specific to the replica. It's called selector. So selector here is also about labeling, but it's a little bit different than just setting up the labels in metadata. It allows us to search for the pods, and for a replica set, it's kind of a controller, and the pods are simple, like separate entities. So the replica set kind of needs to find its own pods somehow. So the selector works for that. It kind of helps to say that this is your pods from this replica set. And actually, it's very similar to deployment. In deployment, we also have this structure of selectors. And then we have a metadata part. And you can see also a new thing here, which is with new template. So template here means the template of the pod description. So replica sets and deployments all have their templates because they just create multiple pods. They don't need to set it up from scratch. So we have a template for all of the pods, which gets repeated, and we set it up directly in creation process, like here in the code or in YAML file. So we set up the template of the pod that's going to live for replica set and for deployment. It has the metadata part, yet again, some labels, just as we did for the pod, and it has the name and the image or container. Again, we just set up the Nginx and specific version. And after that, we can add specification of pod and then specification of the replica set. So I would say that in YAML file, it would probably look a little bit simpler. You would just see this kind of nested structure of the pod, and you wouldn't have to dive too much into specifying that it's a template or not. So you kind of get to understand a little bit more about the objects here by writing the code. But again, it kind of takes a lot of space, and you can't actually remember all of these methods. Then you just do very similar thing to the pods. You call this time the replica sets in specific namespace, and then you create the replica set that we specified. And here we are going to see which pods are there now after the replica set is created. So you can see here with labels, and with these labels we get the pods in the namespace which are specific to this replica set, because we are not checking just everything in the namespace. We are checking only the pods of this replica set. And in the end, we just kind of drop it. So we don't need this replica set after running the tests. Now talking about something more complex, I'm going to get back to the slides to explain this example. So we just saw the basic objects like pods, replica sets, deployments. Also, you can see a new one here, which is namespace, but it's very simple. It's creating a namespace in the cluster, kind of dividing your objects between users, for example. And all of these objects exist in the API. So the API can be usually extended, and we can create something custom, which is our own object, any kind we want. So how it works in real-life use cases. For example, big data developers often use Spark, and we need to set up Spark jobs. And since now Spark supports Kubernetes, it's possible to run it on top of Kubernetes. We can just create custom object of a Spark job. So we can set up everything we do in Spark shell for running the job in the YAML file, like a Kubernetes object, and it's going to be Spark job custom object. So in such a way, we can create any kind of custom objects. Doesn't really matter which kind. And it kind of adds up a lot of flexibility when we are building a cluster and some complex pipelines. And also, there are multiple approaches to how we would create these objects. So you can see on one side here with a state, we can create, for deploying the Postgres database, deployment or stateful set. Then we need to set up the volume, all of the objects. And after that, we still need to manage the state somehow. It's stored somewhere in some volume, for example. And we need to build some custom workflows with managing this state. What happens when we are using another approach, which is called an operator, more like a paradigm? So this approach allows us to build it in a much more automated fashion. We run kubectl apply on the YAML file with operator definition. And this operator is not just some abstract one, it's a Postgres operator. So we set up everything we need to the Postgres operator. Then we run apply, and after that, this operator spawns the deployment or stateful set, the volumes, so we don't write them ourselves, and then manages the state in etcd, which is much more safe since it's persistent storage, and you don't need to worry about that. But this process is not fully automated, which is also good because you can set up your own parameters in Postgres operator. Also, all of the objects that are getting created for you can also be edited and changed in any way you want. So you kind of have this initial setup automated for you, some workflows automated for you, and you can build up from there, which is also very cool. So let's see how it looks like. So in Kubernetes, we call custom objects CRDs, or custom resource definition. And here you can see that it's a bit more complex. So we set up the CRD group, kind, version. It's important to set up version and the API that you are calling, because not all of the versions of Kubernetes have custom objects. Also, only specific versions of Kubernetes API have a specific custom object you want to reach out, because You can use them kind of from Helm packages. And you have, again, the namespace. Singular and plural, just comfortable to use when you're querying specific CRDs. And here we just set up the instance name, just use it from both plural and the group. So the definition itself is a bit smaller than the previous one that I've shown, but it actually contains more, because we are reading the file aside of just setting up everything in the code. So here, as I said, we have the API version. So here we use some version beta 1, which contains custom objects. We set up metadata again, the CRD instance name, which the one that we set up is the plural, and group, it's just notation. And then we get to the specification part, where we have kind of the object, plural, group, and then we set up the namespace scope. It can be cluster. And we set up this schema. So what happens here? We have a file called schema file, and it set up the schema for us. It's kind of quite simple. It can be in YAML, can be in JSON. So we set up that there is object with replicas, number 1, and 0 dependencies. So it's quite simple here. There is a bit more complex case that I decided to discover in this example. So aside of just setting up this CRD, for example, we want to have multiple custom objects running in our system, multiple instances. And there are some things in the definition that are going to change because of that. So for example, here's our YAML file, and you can see that it's kind of huge with all the setup that we need for Postgres custom resource definition. And you can pay attention that there are these values that look like to be changed for multiple values. So in this case, for example, we want to run multiple instances of custom resource definition, and we want the name to change. Because of that, we also need to change the singular and plural. And there can be one more case depending on the custom object. For example, we want to change the path to some file or anything else that's going to change over the test. So we want just to have this template and these values to be changed over time. How we are going to achieve that? And I would say that it's a little bit manual process. So we can approach it as the thing that Kubernetes YAML file looks like a map. You can pay attention that we have keys and values, and we have nested maps. Like metadata, that's the value, and for the name to be changed is going to be the value. So that's how I approached it. Just going to show another class that I created for it. So what happens here? We just read this file, and this is just helper methods for reading the files. And we convert our YAML file to a map. So we read our YAML file, we get it as input stream, and we set it up as a YAML file, which is actually a map. So we set up our file as a map of YAML file in a way. And you can see that the result is a hash map of string with the value of string and object. So we have nested maps here. What we want to change is here. So we have one nested map here, spec, which also has names, and then only plural and singular. And it looks like it's easier to change metadata because it has only one level, like metadata, then only value, and then again we get like lower. So let's start exploring how to change metadata. We just get the metadata as a key and put the value here into the name key. So it's quite simple. Here it's kind of similar, but we change two values. So we get the specification, we get plural and singular from there, and put new values that we want there. And pay attention that we get, as a result, the specification and the metadata, and we kind of return them because we are going to set up them again in a map. As I said, we have a nested one. So in the end, we get back to the YAML file being a map with spec and metadata, and we just set up this new specification and new metadata that we edited and returned YAML object. And after that, YAML has this method which allows to provide the values as a file or as a string. So we just build a string from all of these nested maps, provide it to the YAML, and here what we get. Yeah. So we have this YAML string. In the end, we have new YAML file that we built from kind of getting into the map. And it's a bit manual method because there are no functionalities in the library which would allow to edit these values in case we would need to do that. And here you can see that we are just loading these files, using the method custom resource definition, then we create it. Or replace means that sometimes we can have already running custom resource definition, so we need to check ahead that there are no other objects running in the system. So we run this create or replace, and after that we list all the CRDs and namespace. Again, just check that it was created, and they are created. We check the pods just in case, and then we can purge everything by just removing the CRD specifically. So this example itself is a bit more complex than the previous ones. If we wouldn't need to edit the CRD file somehow, it would just look like this. And we would just add some more parameters manually instead of just specifying the YAML file. But you can also see here the example of the fact that we can supply partially some parts of the definition as files, which can be easier aside of just having this long definition or this, which is even longer. So this is it for the Fabric.io library. Now we are going to look into AskKuber and see if it's more simple or is it similar. So here we have the actor system. Because, as I said, AskKuber relies on akka, which uses actor system, and we just initialize it a little bit differently with the client and Kubernetes config. And here the creation of the pod looks much more simple. We just set up the container, the name, the image, the command that happens here, let it just be some busybox just for the sake of the example. And again, it's just a blueprint for the container this time. So we specify this blueprint, we then set up the pod with a specification and supply the container definition here, and here is it. We are creating it using create method, which also looks simple. So you can see that the definition here is much shorter. So we just call create, and we can supply some specific information like the name of the pod, the container, and that's it. We don't need to write all of these parts which are about metadata, specification, and all of that. And after that, we can do the similar thing by checking the pods in the namespace that were created. And here the process looks a little bit different. So we are relying on futures here because using the Akka library behind the scenes. So we call this list in namespace. The type of the object would be pod list, which is just a list of pods. And then only on complete we can check that actually we can get the pods and see what's running in the system. And in the end, we can also call delete on specific pod with a specific name. And again, we are relying on future, so we are setting up the wait result here. And in the end, we can just call close. So the replica set example would look just the same. We would just set up the replica set, the container, call create replica set, and everything else would look just the same. That's why I didn't specify it here. And you can already see here that actually this example looks more simple than the one in the previous client. And also talking about Kubernetes Java client, which I didn't show in this example, so it looks even more complex there. So it's less of the code with AskKuber for especially Scala developers. But I would say that it's probably not very good that it's relying on Akka because it's kind of limiting our abilities here. And talking about CRDs, so CRDs here, we just again specify the same initialization, which is just the same for each of the creation. And the custom resource definition looks a bit simpler. So we set up this custom resource definition, we set up the name, the kind, let it be a team for the specific CRD, and the scope cluster. And we can set up also short names. And then other CRDs would work as a service, so we specify the name, kind, and short names. In the end, we just call the save, which would help to create those objects. So here's the method. So it looks like this, because we need to check if any of the CRDs already exist in the namespace. As I said, it can happen that we already created the CRD and we didn't purge it somehow. Therefore, we still have some CRDs running, which is not good, and we need to. And if you would try to create something again, it could throw an error. So because of that, we check already exists. And by this method, we also can modify one. So if we have some running CRD with name CRD1, let it be, and then we are creating a CRD with CRD2 and some other specifications in metadata or spec part, we can just update the existing one instead of just kind of throwing an error. So it's a bit simpler. And here we just call this save method, which checks if it exists or not, and then creates a new one. And we have, again, the checks of closing down the CRDs or deleting them with onComplete, again, to handle the futures. So we just terminate everything as soon as we don't need it and close the client. So getting back to these slides. So as you could see already, the approach is kind of similar for both of the libraries, where we can set up the object, we can modify this object, we can also scale the instances. And just as I shown with Fabricate.io, we can even build up our own custom functionality, like for example, running some changes in the file parts if we want to do that. So it's not easy in this case, but it's possible to build some custom logic. And you can see that only in this case of changing the YAML files, we actually used YAML files. So before that, we could just write in the code that we want to create a pod and then do everything else in the code without actually working with YAML files or setting up something in Kubernetes specifically. So it's very simple because of that. And with skuber, you could see that actually you just write like create, specify the name, the container, and that's it. And you just check that something is created, that it's running in the namespace, and it's all correct one. So I hope that this was useful for you. And actually, the idea was to show you that being a Scala developer or developer in any other language, you can find a way of working with infrastructure closer, like Kubernetes specifically. So you can just create objects again, modify them, and it's not that complex if you want to just start out instead of just like digging into Kubernetes API and figure out all of the objects. You can start with a library like this one, like any of the libraries that I've shown, and figure out on the way and experiment a little bit, and it could be easier and more fun for us being developers aside of being aside of the people that work with infrastructure every day. So I hope that it kind of brought this idea of having a possibility to work easier with infrastructure. Thank you for attention, and I would be happy to hear all your questions.
Okay, so everybody understood everything Roksolana just said. All right, I have my own question to you. Roksolana, clearly coding is your element, right? My curiosity is, how did you start? And let's say there's a young girl who is thinking about getting into coding, who's watching you right now. What would you tell her? What would be your recommendation how to get your hands on it?
I would say that it's good to practice as much as possible, because it's always hard in the beginning as everything which is new. I had a lot of examples of people around me when I was at school and just studying and realized that I want to try programming, and then got into it. And over the years, I switched between different languages, between different spheres. Like now I'm in big data, before I used to be a backend engineer. So it's always good to try different things and understand what it's like closer to you and what you want to do.
Thank you very much for that. I hope we inspired someone today to join your life. Thank you very much, everyone, for listening. And if you have any questions, you can catch Roksolana throughout the day.